Hey Geometry, this is notes number 4 of Unit 2. Our learning target for today is I can apply the exterior angle theorem. So in our warm-up activity, we discovered this theorem. The measures of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So if we're looking at this diagram, my exterior angle is angle 4, and my remote interior angles are the angles across the triangle from it. So that would be angle 1 and angle 2. They're called interior because they're on the inside of the triangle, and they're called remote because they're like on the opposite side. So our exterior angle theorem would say the measurement of angle 4 is equal to the measurement of angle 1 plus the measure of angle 2. So we can actually prove the exterior angles theorem in triangles. But first, we are going to prove the triangle angle sum theorem. So in order to do that, we need to use an auxiliary line. So an auxiliary line is a line added to a diagram to complete a proof. So for this proof, we're given triangle ABC, this one right here. So in our proof, we are trying to prove that the three angles inside our triangle add up to 180 degrees. So we saw this in our discovery activity, but now we're going to go through what the actual geometry proof would look like. So in our proof, we're given triangle ABC. That's our first statement. The next statement says to draw the line XY through point B parallel to segment AC. And the reason we're allowed to do this is because it is an auxiliary line. So on my diagram, I just created these lines so that they are parallel. So I'm going to draw that information on here. I know these lines are parallel. Statement 3 says the measure of angle 1, this one right here, is equal to the measure of angle XBA. So that would be this one. It also says the measure of angle 3, this one right here, is equal to the measure of angle YBC, this one. So we are allowed to say that those angles are equal because I'm going to draw some things on our diagram up here. These lines, I'm going to kind of extend this one out so we can see it a little bit better. Our line at the bottom and the line at the top are parallel, which means angle 1 and angle XBA are alternate interior angles. And the same thing is true for angle 3 and angle YBC. So my reason here is alternate interior angles. Okay, so from here, we are saying the measurement of angle XBA. I'm going to erase my marks on my diagram just so that I can mark it up for this next step. The measurement of angle XBA plus the measurement of angle 2 plus the measurement of angle YBC is equal to 180 degrees. Well, if we look at those three angles, the ones that I highlighted up here, those angles create a straight line. So they add up to 180 because they are supplementary angles. And in the last line, it says the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 equals 180 degrees. Well, how did I go from line 4 to line 5? What happened here? Well, if I look at this, the measurement of angle XBA changed into the measurement of angle 1. Angle 2 stayed the same. The measurement of angle YBC changed to the measurement of angle 3. So what happened is I substituted. I know that angle 1 is congruent to the measure of angle XBA, so I can just swap those out. So my final reason here is substitution. So using things that we already knew, like alternate interior angles and supplementary angles, we were able to prove the triangle angle sum theorem, that all three of the interior angles add up to 180 degrees. So we are going to use this theorem to prove another. So this time what we're given is triangle ABC, and we are trying to prove the alternate, nope, that's not what it is. We are trying to prove the exterior angles theorem. So that's proving that angle 4 is equal to angle 1 plus angle 2. So given this diagram, my first reason in my proof is given, always. The next statement in my proof says angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. Well, we know those three angles add up to 180 degrees because we just proved that. That is true because of the angle sum theorem. Oh, sorry, the triangle angle sum theorem. Our next statement, the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Well, those two angles are a linear pair. They make up a straight line. Our next statement says that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4. Okay, that makes sense because they are both equal to 180 degrees. So this is a case where we substituted. Instead of saying 180 degrees, now I'm saying something that's the same as 180. We swapped those out. So statement 4 is substitution. And now in statement 5, we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Well, if we look at what happened between statement 4 and statement 5, angle 3 disappeared. There was a measure of angle 3 on both sides of our problem, but now it's gone. So how did we get rid of it? We used, let's use a pen. We used the subtraction property of equality. So now we know why these theorems work. Let's apply them to a problem. So on our examples, we are going to be solving for x using the exterior angle theorem. So my exterior angle theorem says the two angles on the inside, when they add together, they equal the angle on the outside. So for this first one, I can just say that 56 plus 47 equals x. So would that be the 103 is equal to x. Okay, for number 5, we're still looking for x. This time I know my exterior angle is 90 degrees. I have one interior angle that's 34, and the other one is the angle measure I don't know. That angle measure is x. So my exterior angle theorem says the two angles on the inside add together equal the angle on the outside. So x plus 34 equals 90. So to solve this one, I have to subtract 34 on both sides. And we end up with x equals 56. We can also apply this to problems that involve a little bit more algebra. So for number 6, we are looking for the measure of angle CAB. So we are trying to find the measure of this angle right here. In order to find that measure, I need to know what x is. So I'm going to start by applying my exterior angle theorem. These are my interior angles. When they add together, they should equal my exterior angle. So when I add these together, 8x minus 1 plus 4x plus 8 equals 91. If I combine my like terms, 12x plus 7 equals 91. And then if I solve my two-step equation, I would subtract 7 on both sides. So 12x equals 84. Divide by 12 on both sides. And x equals, oh, I don't know, doing math in my head. 84 divided by 12 is 7. Thank you, calculator. So I found that x is 7. Now that I know that, I can find the measure of angle CAB. Angle CAB is labeled as 8x minus 1. I can substitute the 7 in where x is. 8 times 7 is 56. So that angle measures 55 degrees. All right, try the problems on the bottom. I'll have the filled in answer key posted for these. So make sure after you try the problems on the bottom, you check your answers with the answer key on Google Classroom.